All right, folks. For this particular problem, we're going to ask to use properties of logarithmic functions and trigonometric functions both to be able to write this problem as a single logarithmic function. It'd be even nicer if we could write it without a fraction, but we'll see what happens.
Oh my lord. I think I look at the picture right now. I think I've seen a problem like this. I was on texting and he was like, you're gonna hate college math, and it was a picture just like that. Hang on. I'm gonna find it.
And so, by the way, yes, I just made this thing up, so we'll see if it works.
According to the combination properties, log b of u plus log b of b is equal to log b u b.
So what you're telling me then is I'm going to kind of think about it like this, those two together.
Yes, and then the other side is log bu minus log bb.
Now be careful, let's look at it a little more closely. You'll notice that both of these are minuses.
Yeah.
So if I actually draw in that bracket right there, that's going to turn that into a plus, correct? So let's kind of work in those two brackets first and see really what happens. And you're telling me that if I have plus between my logarithms, what do I do with these parts of the logarithms? So basically I end up with the ln of the absolute value of 1 plus the cosine of x times 1 minus the cosine of x. Is that right? And then I've got subtraction here, the ln of the absolute value, 1 plus sine of x times 1 minus sine of x. That's what I've got, right? So it looks something like that now. That's a little simpler. Not much, but a little bit. Can I multiply 1 plus the cosine of x times 1 minus cosine of x? Can I multiply that out? And can you multiply out 1 plus sine of x times 1 minus sine of x? Okay, so go ahead and do that. Do you find what you were looking for back there?
Yeah, and it was like that divided by a function that was like logarithm math.
Yeah, that sounds about right.
Yeah.
On the left, it's the same problem we've got in textbook tonight.
No, it won't be the same question you got in your textbook tonight. I won't assign it.
Well, no, the one that she
Oh, no,
has.
that won't be it either. So as you're multiplying out 1 plus cosine of x times 1 minus cosine of x, what are you noticing that happens right here?
You get ln of 1 minus cosine square x.
And if I take 1 plus sine of x times 1 minus sine of x, over here, what does this product become?
1 minus sine squared.
Yeah, by the way, do I still need absolute values on these two things?
No, because they're already squared, so it's only going to give you a positive.
We got to be careful about that statement. We've got 1 minus the cosine squared. What's the largest the cosine can become?
1.
You got to get a 0 out of this. We got to be careful about that. We actually cannot take the logarithm of a 0. So actually we can't have that. But we'll get there in a minute. We've got one of two directions to move here. We can either work on our logarithmic properties and combine them together, or we can look at our trigonometry and see if there's any substitution we want to make. It's up to you guys.
Do the log one. Do the log.
Yeah.
Do the log combination first? Okay, so if I've got the logarithm of this quantity minus the logarithm of this quantity, using your logarithm properties, how do you combine them?
Division.
So we have the ln of the absolute value of 1 minus the cosine squared of x over 1 minus the sine squared of x. Do you agree with that?
Yes.
Okay, any questions about this? Well, you know what? We've narrowed it down to the single logarithm. That's helpful. So should I say clearly this is equal to 2 ln of the absolute value of the tangent of x? Can you agree with that?
Where do you get the 2?
Oh, so it's not clearly. Okay. Don't ever let a professor tell you clearly something's true. Make them explain it if it's not clear.
So where are we pulling this from?
Well, that's the explanation part. Do we have anything that could be replacing the 1 minus the cosine squared of x?
Yes.
I just want to look at that numerator. I don't want to look at the whole thing. That would be correct. You guys remember that post-it note we used last time? You looked at it yet?
Oh.
What about 1 minus the sine squared of x? What does that become? And doesn't that actually stem out of our Pythagorean identities?
Yeah.
Okay. So now I have the sine squared of something divided by the cosine squared of something. Can we replace the sine of u over cosine of u with something equivalent?
Tangent of u.
So would you agree that this is equal to the absolute value of the tangent squared of x? Okay. So then why would I write 2 ln tangent of x? Absolute value tangent of x.
Pull the 2 from the tangent.
One more of our log properties, if we have an exponent here, can come out in front. So does it make sense now that I have that answer? It would not have been wrong the other way, but
It's more right.
it's kind of more simplified, and there's some calculus reasons why we want it in the bottom way instead of the top way. Yeah, that was interesting. I'm hoping this reminds you of some of your logarithmic properties and some of your trig properties. That's part of what this is about. Any questions about this?